Hello, good afternoon, Pranay and Pawan. Um, since it's the first day of the problem solving session for this uh, course, maybe we'll wait for a minute or two for there's more people to join. Okay, so um, welcome to the problem solving session for this course, Availability and Management of Groundwater Resources. My name is Shruti, and I'm a PhD student doing my PhD in IIT Palakkad. Am I audible? Can someone just confirm if I'm audible? Okay. So yes, these sessions, to just brief about what these sessions would be, it would be problem solving sessions generally. So this is actually going to help you people to help you with the assignments that are given to you every week. And all these problem solving sessions will be based on the lectures that has been undertaken in the corresponding weeks. So based on that, I will be discussing some sample questions. Since in this case the problems are, I mean, numericals are a little bit less. I'll be dealing with theoretical questions coming from the content of the week's lectures, and we'll discuss about the problems. This will help you do the assignments that have been given to you for the corresponding weeks. So I usually conduct the sessions so that it will be an interactive session in such a way that your input is also involved. So I'll be showing some questions on the screen. No, Pranay, there is no attendance for these sessions. You can attend these sessions to clear your doubts regarding assignment problems. The YouTube video will also be uploaded, and I believe the presentations also will be available to they'll be sharing you a link or something which has the sessions. So the attendance is not mandatory. This is just to help you with the assignment problems. It will be good if you attend the sessions. Yes, so that is the objective of these problem solving sessions, to practice problems related to the lecture content that is being conducted. So like I said, I'll be showing some problems on the screen. You can input your answers. All of the questions are objective, so there'll be options provided. Uh, you can put in the answers that you feel are right in the chat box, and then after that we'll discuss the associated theory of those questions. So I think it's about time. We'll start with the questions. So this week we are dealing with the first week lectures, questions related to the first week, which includes the hydrological cycle and need for conservation of groundwater resources, the first 5 lectures. So I'll start the question discussions. So this is the first question. What is the continuous cycle of evapotranspiration, condensation, and precipitation known as? So you can type in your answers in the chat box, and then After that, we'll discuss the solution. If you haven't attended the session, just go by what you know. Anyhow, just type in all your answers in it, and then only after that I'll be moving on to the solutions. So what is the continuous cycle of evapotranspiration, condensation, and precipitation known as? There are four options. A is runoff. One is Earth's water budget, the B option. The water cycle, C option. The hydrogen cycle, D option. Okay, thank you, Pawan, for the answer. Anybody else? Please go ahead and give in your answers. As you do it along with me, this is actually going to help you. I mean, you won't have to then again keep repeating such terminologies when you're preparing for your exams. So you can utilize these practice sessions to um, familiarize with the concepts, and as you do problems, it will be helping you only. So just go ahead with the whatever answer you do. Okay, Pavan has given us runoff. Okay, I'll go on to the solution. So the answer for this is the water cycle. Correct. A bit late though. Gopala Krishnan has given water cycle. So yes, what the answer that you have given is right. So hydrology, as we all know, hydrology is a study of occurrence and movement of water. I mean, the presence of water is sustained by this cycle called hydrological cycle. And hydrological cycle is when water is circulating among the earth surface, below the earth, the atmosphere. It is a continuous cycle, and we can categorize this hydrological cycle into two phases, or two phases actually. One is the atmospheric phase, and another one is the terrestrial phase. So as the name suggests itself, atmospheric phases where the water circulation is happening in the atmosphere and the earth's surface, and terrestrial phases nothing but the cycle that is happening between the surface and below ground. So hydrological cycle, so if there are people who are not familiar with what a hydrological cycle, it is nothing but from oceans, water is going to evaporate. It is going to the atmosphere. It is going to condense into clouds. Then again, it's going to rain. Precipitation is going to happen. Rainfall, snowfall, and all will happen. Then it will come down to the Earth's surface itself. It will flow through the Earth's surface. Some will go below. Some water will flow through the surface, and it will reach the oceans again through a number of streams and rivers, and also this continuous cycle of water within the Earth's atmosphere and the surface and the below ground is called the hydrological cycle. So, like I said earlier, hydrological cycle is separated into two phases. For easy understanding, we can separate it into two phases. One is the atmospheric phase, and the other one is the terrestrial phase. So atmospheric phase, like the name suggests, is whatever circulation is happening in the atmosphere. So it can be in two forms: the liquid atmosphere and the Earth's surface. So in the atmosphere, the gaseous form of water that is available is water vapor, and on the surface, when precipitation falls off in the form of rain or snow, which is the liquid and solid phase, it will exist. That is another category of water that is present in the atmospheric phase. So water vapor, the movement of water vapor in the atmosphere and the movement of rain and snow in the atmosphere is coming under the atmospheric phase in the hydrological cycle. So when we come to the terrestrial phase, it is a water cycle or components of water cycle that is happening between the surface of the earth and below the surface of the earth. So that is called the terrestrial phase. And in the terrestrial phase, okay, and the terrestrial phase, there is a surface and a subsurface. So what are the water movements that are happening on the surface? Some of the water movements that are happening on the surface is runoff water, which is flowing off on the surface, flowing off into rivers and streams from the surface of the earth. That is called runoff. And stream flow, which is nothing but rivers and lakes and the flowing rivers and lakes and all. Now, subsurface water movement includes water that, when it rains, the water that will enter the ground surface. Processes like infiltration and percolation. That is another category, or that is another component of the hydrological cycle that is coming under the terrestrial phase. And also, groundwater movement is also one component of the hydrological cycle that comes under the terrestrial phase. So, water, like I said, is in continuous motion. There are various components. Precipitation, evaporation, all these processes are coming under the atmospheric phase, whereas processes like runoff, infiltration, percolation, groundwater movement, stream flow, and all are coming under the terrestrial. So our question was what is the continuous cycle of evapotranspiration, condensation, and precipitation called as? These are all components of the hydrological cycle. Another simplified term used for hydrological cycle is the water cycle. Okay. Next question. Please put in your answers in the chat box. If the rate of rainfall is greater than the rate of infiltration, then what is the excess water that is accumulating on the surface called as? What is, or you can reframe the question as, what is the process or what is the component of the hydrological cycle happening when the rate of rainfall is greater than rate of infiltration? Go ahead and put in your answers in the chat box, and then we'll discuss the solution. Yeah, so Badrinath, Gaurav, Shinde, Pavan, please put in your answers, whatever you know. Nothing wrong or right, whatever you know. We're anyway going to discuss the solution, so you just put in an option which you think is right or which you know is right. Okay, so I think I don't seem interested in, or I believe you're not familiar with the term. So okay, I'll go ahead with the solution. So the answer for this question is surface runoff. So we know what runoff is. Runoff is the water that is flowing through the surface of the earth into rivers and streams and lakes. When the rainfall that is falling on the surface, it uh, it will first start entering into the soil. At some point, this rainfall that is entering into the soil will stop because the soil gets saturated with water, and it will not be able to enter into the soil. So in this condition, what will happen is the rainfall will stop entering into the soil and it will flow off. This is what is called as surface runoff. So surface runoff is generally occurring when the rate of rainfall is greater than the rate of infiltration. Infiltration is nothing but the movement of water into the soil. As soon as it rains, water is going to seep into the soil, and that initial movement of water into the soil is called infiltration. So when the rate with which the rainfall is happening increases the rate with which the water is entering the soil, water will not be able to enter the soil. It starts flowing off. So that process is called surface runoff. Let's just give an idea about the other terms. Surface depression is nothing but there are on the surfaces are very uneven. So there will be holes, potholes, low points on the surface of the earth. And in this surface, when it rains, water will accumulate in these small holes and all, called depressions. So such storage or such a process is called the surface depression. So water being stored in such small holes and depression is called depression storage. Now, what is surface detention? Surface detention is nothing but uh, just before water is going to flow off into the rivers, or just before water starts infiltrating into the ground. This is a brief momentary time when the water will be there on the surface. It's not accumulating on the surface, but it is going to uh, be there for a momentary or temporary time, and then after that only it is going to flow off, or it is going to enter the soil. Such a process or such a state of water at that state is called surface detention. Now, surface discharge is nothing but anything that flows over the any water that is flowing over the surface into whatever water body is called surface discharge. So runoff is something that is coming under surface discharge. Surface discharge will also comprise of wastewater flowing from the surface. If the storm water that is coming out of the drains are flowing from the surface, all of this is coming under surface discharge. Runoff is one part of the surface discharge. So that was the second question. Now we'll move to the third question. Which of the following is source of groundwater? Again, this is a very simple question. We know what lakes are, we know what streams are, springs are, ponds are. So which out of this is a source of groundwater? Again, please put in your answers. Again, if you actively participate only, then I will be interested in taking the class. So let's make this interactive. If you have any doubts, you can ask. If you're not comfortable using the mic, you can put it in the chat box. Again, given your answers, this is going to be helpful as it will be a practice for you. Okay, I think I'll move on to the solution. So, a source of groundwater is the spring. So here they're given four water bodies: lakes, streams, springs, and ponds. So the remaining three, lakes, streams, and ponds, all of them are surface water sources. So water availability through lakes, ponds, streams, rivers, storage reservoirs, and all these are surface water that is available to us. Groundwater can be accessed through springs, infiltration galleries, dug wells, tube wells, artesian wells, etc. So spring is, coming to the answer over here, spring is a source of groundwater, while the remaining lakes, streams, and ponds are sources of surface water. So just to familiarize with what, just to give you an idea about what these are. Infiltration galleries are nothing but structures like this underground. So if the water table is this, they'll build such compartments which is able to take in water from the water table through these drains, and then store it in a compartment, and then this compartment can be accessed through some kind of accessible pipe or something like that. So this form of storage facility is called an infiltration gallery. Basically, this infiltration galleries are built next to rivers because the water table will be higher in these regions. This is infiltration gallery. Now, artesian wells. These I'm just talking about some of the sources of groundwater that is I had shared earlier. Here I was talking about the sources of groundwater. We all know what lakes, ponds, streams, rivers, and all are. Springs also, we know what springs are. When the groundwater that is flowing, there's an obstruction or there's a cutting, then that groundwater will start falling off from the interior layers of the ground. That is called a spring. Here, an artesian well is nothing but again this when a well is placed in the water table, out of pressure the water starts flowing off. Here what you see is an artesian well. So you just have to uh, construct or dig a well or insert a tube and make a facility for water to come out of this aquifer. And aquifer is nothing but water bodies, the groundwater bodies underneath the soil. So water will start coming out as a result of the pressure, water pressure. So this is an example of artesian well. Here what you see here is a tube well. Tube well, I think most of you will be familiar with that. It is, into the confined aquifers, the bores are constructed. So water that is coming out of deep layers of the soil is also another source of groundwater. Okay, let's move on to the fourth question. Process in which water is absorbed by soil of any area by the downward movement of water during a rainfall is. So we pretty much discussed a lot of terms that you see over here: infiltration, percolation, condensation. Again, we've all learned it in school, sublimation and all. So what could be the answer? Type in your answers in the chat box. For those of you who have joined newly, you can put type in your answers in the chat box. And once after that, we'll move on to the solution. Okay, Gaurav has said it's infiltration. Any more answers? After that, we'll go. Okay, so let's move on. So yes, your answer is right. It is infiltration. So infiltration is the process by which water enters the topsoil or water enters the soil once rainfall happens. Now, what is percolation? Percolation is nothing but the water first, the initial water that is entering into the soil, that process is called infiltration. Now, once this water enters the soil, it is going to again move downwards due to the force of gravity into deeper layers of soil. Due to gravity as well as capillary action, it will start moving further down into the subsurface. That deep movement of water is called percolation. Condensation is again when water vapor is changing into liquid state, and sublimation is when solid water is changing from the solid state to vapor state. So a very common question that is asked during interviews and in a lot of comprehensive exam is the difference between infiltration and percolation. So infiltration is the process by which water starts entering the ground surface once rainwater falls on the surface, and percolation is the deeper movement of water into the subsurface layers as a result of gravity and capillary actions. So that's a solution for this question. Now moving on to the next question. What will happen when precipitation exceeds evapotranspiration and runoff in an area? For those of you not familiar with what evapotranspiration is, precipitation is nothing but rainfall and snowfall. Evapotranspiration is a combination of evaporation as well as transpiration. So transpiration is nothing but water that is being transpired by plants. Vegetation is going to they're going to send off some amount of water into the atmosphere. That process is called transpiration through their stomata. Evaporation is nothing but the water that is going to be evaporated from the surface of the soil, from the soil surface, from the surface of the plants. Now, water that is being absorbed by the plants, when they remove it from the plants through this process, it is called transpiration. Now, water, if it falls on the surface of the leaves, if it is getting evaporated, that is also coming under evaporation. So this combination of evaporation and transpiration is called evapotranspiration. Runoff, again we discussed the flow of water when rainfall is when the water stops infiltrating, it will flow over the surface into water bodies. Okay, we have an answer here. Someone said it's irrigation. Thank you, Pavan, for the answer. Does anyone else have? So what is occurring when the precipitation is exceeding? That is, if it rains more than if water that is lost through evapotranspiration and runoff is less compared to what if it is raining, what happens? What is the probable situation that might happen? Is it going to okay. Um okay, I might in 10 minutes my meeting might end up, so I'll rejoin. You also please rejoin the meeting. I don't know, there's something wrong with my link. Sorry for the trouble. When this meeting ends, please rejoin the meeting. Okay. Just a second. Okay. So what is the answer? Pavan has told it is irrigation. Or wait, I think I'll put one more. Please hold on for a minute. I'll share another link with all of you. So I've shared this meeting link. Please save this, and once this meeting ends, can you please join the new link that I've shared here? I'm sorry for the inconvenience caused. This meeting will supposedly end in 10 minutes. Is there anyone who has a doubt about it? Please save this link and join this link once this meeting ends. I'm not going to end it now, but once it ends, please join in this link. Okay. I hope I'm clear to all of you. Okay, so let's get back to the solving. Okay, so we were in question 5. Badrinath and Harsha, I guess I'm clear to you. Please share the link that I've shared in the chat box. When this meeting ends, it will end in 6 minutes or something. So please rejoin in the other link. Okay. Okay. So let's move on to this question. The answer for this question, it is moist soil and possible flooding. So just think of it. When water, it is raining and raining, it keeps on raining. At some point, the water is going to get accumulated on the soil because it's going to saturate the soil because the evaporation occurring is not at the same rate at which the precipitation is occurring. So the soil is going to be moist, keeps getting moist, and there will be possible flooding when the precipitation happens in excess. So the correct answer for this question is C. Okay. So next question, again, please put in your answers. In addition to personal use by people, large amounts of water are also used by uh, which what part of the society? Is it used for agriculture and industry? Is it used in colleges and university? Or is it for mining and manufacturing? Or is it for agriculture and water parks? And these are basic questions that just require common sense. So in additional to domestic use, what other sections of the society uses for what other activities is water majorly used? Is it option A, B, C, or D? Okay, I'll move on to the answer. It is agriculture and industry. That we all know colleges, university, mining and all. Agriculture is the largest consumer of water in India particularly. So these are the sectors which uses a large amount of water apart from domestic use and commercial use. Now next question. Water budget equation can be expressed as what? We know what a water budget equation is. Inflow minus outflow is what? So what is the answer over here? Option A, change in mass storage is equal to outflow minus inflow, or is change in mass storage plus the outflow equal to inflow, or is it change in mass storage minus outflow equal to mass inflow, or change in mass storage equal to mass inflow or mass outflow? Please put in your answers, Harsha and Badrinath. You know the answers. Even if you don't know the answers, just go through the options and see. Okay, so the solution is change in mass storage plus mass outflow is equal to mass inflow. So the water budget equation is given by mass inflow minus mass outflow is equal to change in storage. So they have just brought the mass outflow term into the LHS. So whatever water is coming in will be the water that is going out, and if there is a difference in the quantities of water coming in and going out, it will be because it is stored somewhere on the earth surface. So this is the basic of what mass flow water budget equation is. Now this is the numerical. Okay, it only seems like Harsha is here. Harsha, can you join the link that I provided in the chat box? In that case, we can discuss these questions over there. Badrinath also, if you can join the link that I have put in the chat box, we'll go ahead and see there, discuss the questions there. I hope I'm clear to you, Badrinath. You can join in the link that I posted in the chat box, and I'll meet you there. The session is not over. I'm just asking you to join another link. Thank you. So I hope my screen is visible to you. Yes, so here the question is, a river reach has a floodway passing through it. At a given instance, the storage of the water in the reach was estimated as 17.5 hectometer. And what would be the storage in the reach after the interval of 3 hours? The average inflow and outflow during the time period are 16.2 meter cube per second and 12.6 meter cube per second respectively. So please go through the question. Okay. So here they're saying that a flood wave is passing through a river reach. That time the storage of the river is 17.5 hectare meter. Now what they're asking for is a storage after 3 hours when there's an amount of water that is flowing into it at 16.2 meter cube per second and moving out of it at a rate of 12.6 meter cube per second. Okay, so let's move on to the solution. The correct answer is option C. So let's see how we have got the answer. So the initial storage they have provided is 17.5 hectare meter. Now when we know that whatever units they have mentioned here is in the form of meter cube per second. So let's convert this to units of meter cube. So 17.5 hectare meter means 1 hectare is equal to 10 to the power 4 meter square. So 17.5 hectare meter is equal to 17.5 into 10 to the power 4 meter cube. Now they have said that the water that is entering is at a rate of 16.2 meter cube per second. So yeah, the storage of with such an inflow rate for 3 hours will be multiplying 16.2 with 3 hours. So when you converted it into seconds, it is 16.2 into 3 into 60 into 60, which will give us 70,4960 meter cube. The same way, they have also said that the outflow rate is 12.6 meter cube per second. And again, for 3 hours, when you outflow volume calculated with this rate for 3 hours will be 12.6 into 3 into 60 into 60. Now, what we require is the final storage. So, from the water budget equation, we know that mass inflow minus mass outflow is equal to change in storage. Change in storage is nothing but what is the final storage minus the initial storage. So, we know what is inflow, that is this value 1,74,960, and we know what is outflow, that is 1,36,080. Final storage we have to find out. We know what is the initial storage. Initially, the river reach had this much water, 17.5 to 10 to the power 4 meter cubes of water. So from this, we can find out what the final storage is at the end, which is this answer. So this is how the problem is done. If you're familiar with the units, you can actually convert the units and subsequently find the solution. Moving on to the next question. In a reservoir, it is given that the seepage loss is equal to 2.5 centimeter, precipitation is equal to 18.5 centimeter, and evaporation is equal to 9.5 centimeter. Calculate the change in storage. Again, this is based on the water budget equation. They have said that seepage loss. I've kept this diagram just to make you understand what seepage loss is. So seepage loss is nothing but seepage loss is water that is going in. If this is the reservoir, water that is entering the ground through this reservoir is the sea water that will water contributing to seepage loss, water that is evaporating, and precipitation is the rainfall that is happening. So based on the water budget equation, we are supposed to find the change in storage. Okay, so moving on to the answer. So again, based on the water balance equation or water budget equation, we know that change in storage is equal to mass inflow minus mass outflow. So what inflow component that is available over here is precipitation. Precipitation is what is coming inside, which is given as 18.5 centimeter. And what is going outside, flowing out, is the seepage loss and the evaporation. So P minus uh, a total of this evaporation and the seepage loss will give us the change in storage. So since the answer available here is in meters, we'll convert it to meters. It is 0.185 minus 0.025. It's plus 0.095 over here. So we will get 0.025 plus 0.095. Sorry. 0.065. So it will be 0.065 meters. So the answer for this question is answer option C. Moving on to the next question. The highest percentage of freshwater resources exists in the form of, does it exist in the form of rivers or streams, lakes, ice caps and glaciers, or groundwater? So again, type in your answers. Okay, so moving on to the solution. So this is the global distribution of water. Water, that is the total water, global water available to us. 96.5% of it is available in the oceans. 0.9%, around 0.9% is available in other saline forms. Freshwater availability is only 2.5%. Now again, in that 2.5%, 68.7% of the 2.5% of freshwater that is available is in the form of glaciers and ice caps, and the remaining in the major portion is the groundwater. Surface water and other surface waters like rivers, lakes, and all are coming only at 1.2% of the 2.5% of fresh water. So we should understand how less resources of fresh water we have are available to us, and understand the importance of conserving those fresh waters because it is very less in quantity to us. So the question here was, out of the fresh water, which is the highest percent of freshwater resources existing, in what form is it existing? So we have freshwaters available in the form of rivers and streams, lakes, ice caps and glaciers and groundwater. According to the statistics, we can see that highest form contributing to freshwater is the glaciers and ice caps, and next is what groundwater is. So the answer for this question is option C. Moving on to the next question. Which out of these Indian states have the highest groundwater resources? Is it Kerala, Punjab, Karnataka, or Uttar Pradesh? The question here is, which out of the following Indian states have the highest groundwater resources? So let's just go through briefly go through the groundwater resources in the states of India. So you can see some huge numbers here. Andhra Pradesh has got 35.89 billion cubic meter. And if you go to Assam and Bihar also having a huge amount. The question here, one of the options is Karnataka. Karnataka has only 17.03. Then we come to Kerala. It has got 6.69 only. Punjab has got 22.53, and Uttar Pradesh is the one with the highest groundwater resources out of all the states. It has got 77.19 billion cubic meters of groundwater resources. So the answer for this question is Uttar Pradesh with 77.19 billion cubic meters of water. So the next question is, out of the total water in the world, how much percentage of water contributes to fresh water? So we had seen the earlier distribution of global water resources. So if you remember that, how much of water is, how much of water does the freshwater resources comprises of is the question over here. Is it between 5 to 7%, less than 3%, more than 25%, only 0.01%? Okay, let's move on to the answer. The answer is option B. Again, we have earlier we had discussed about the groundwater, the distribution of water resources. So we said that 96.5% belongs to the oceans, and it's 2.5% that is belonging to fresh water. So the question was that how much out of the total water in the world, what percentage is contributed by fresh water? It is less than 3%. Exactly amounts to around 2.5%. So option B is the right answer. Moving on to question 13. Which of the following options is the most conventional source of municipal water supply? Is it glacial? When it comes to municipal water supply, it is the most commonly used source of water. Is it water from glacial ice caps, or is it recycled water, sea water, or is it river water? This is a very simple question. Okay, we'll move on to the answer. It's option D. You all know that the one of the most commonly used source of water is river water. So that is the answer for this question. Moving on to the next question. A typical municipal water supply system in a city usually provides water for, is it only for domestic use, only for use in public facility, or for commercial centers, or all of the above? So when it comes to municipal water supply system in the city, They usually provide water for what purposes? Does it provide for domestic use, public facility use, commercial centers, or all of the above? Okay, so the answer is D. Typical municipal water supply system provides water for all the purposes that is mentioned about for commercial as well as public facilities as well as domestic use. Okay, moving on to the next question. The single largest consumer of fresh water in India is what sector? Single largest consumer of fresh water in India is consumed by which sector? Is it the industrial sector, agricultural sector, power generation, or the domestic sector? Okay, let's move on to the answer. So here it's the agricultural sector. In India, this largest consumer of fresh water is uh, agricultural sector. When you take the world, most of the time the developed countries, the industrial sector is the largest consumer of fresh water. So yeah, that's about this question. Now moving on to the next question. Which out of the following comes under the transportation components of the hydrological cycle? Is it soil water, ponds, transpiration, or groundwater? Which so the we studied about the phases of hydrological cycle. Here they have asked about the transportation component of hydrological cycle. So hydrological cycle also seems to have some components, out of which one is a transportation component. Which out of the following belongs to the transportation component is the question. Again, something if you just think a bit, you will understand. Is it soil water? Is it the water in ponds? Is it the process of transpiration, or is it groundwater? Okay, so the answer is transpiration. So hydrological cycle can be classified into two major components. Earlier, what we have dealt with was the phases in the hydrological cycle. One that is dealing with atmospheric and surface, the other that is dealing with the surface and subsurface. Here, there are two components to hydrological cycle. One is a transportation component, another is the storage component. So transportation component is everything, all the processes in which a flow is occurring, like all the processes, precipitation, transpiration, evaporation, infiltration, percolation, runoff, groundwater flow. All these processes are being, there's some sort of flow that is happening. So all these components come under the transportation component. The storage component are the uh, water that gets stored somewhere, like depression storage, storages in ponds, storages in reservoirs, storages in the soil, soil water, groundwater storage. The groundwater is flowing, it will come under the transportation component, and when groundwater is being stored, it comes under the storage component. So these are the components of the hydrological cycle. One is the transportation component, and then the other is the storage component. And in this question, the soil, water, ponds, and groundwater are coming under the storage components. Transpiration is coming under the transportation component. Okay, moving to question 70. Which out of the following is the correct representation of the water budget equation? Yes, so which out of the following is the correct representation of the water budget equation? Please carefully go through all the options. Here P represents precipitation, R runoff, G groundwater flow, E evaporation, T transpiration, and delta S is change in storage. Okay, so the answer is available over here. It's P minus. P is the inflow component, runoff, groundwater flow, evaporation, and transpiration are the outflow components. So mass inflow minus mass outflow is equal to the change in storage. So this is the general water budget equation. P is the inflow component, R, G, E, and T, which represents runoff, groundwater flow, evaporation, and transpiration, are the outflow components. Okay, so let's move on to the next question. Next question. Which of the following does not come under rainwater harvesting? Is it recycling wastewater, rooftop rainwater harvesting, recharge structures for wells and borewells, or is it micro catchment water harvesting? Which does not come under rainwater harvesting is the question. Okay, so the answer, we'll move on to the answer. So it's recycling wastewater. So under rainwater harvesting, rooftop rainwater harvesting, revival of traditional water harvesting structures, micro catchment water harvesting, recharge structures for wells and borewells. These are some of the methods in which rainwater harvesting can be done. Some methods in which water can be sustainably utilized is by minimizing the domestic water consumption, recycling of wastewater, and improved irrigation method. So rooftop rainwater harvesting, recharging structures for wells and bore wells, and micro catchment water harvesting, some methods in which rainwater can be harvested. The recycling wastewater is a sustainable water utilization technique. Moving on to the next question. Okay, it'll be the end of questions for today. We'll discuss some of the questions that were provided in the assignment 0, which is relating to the portions over here. So in the assignment 0, Yeah, the first question was, which of the following reservoirs contains the most water? Is it the atmosphere, biosphere, groundwater, or lakes and resources? So here, biosphere, the option biosphere is nothing but it is comprising of the atmosphere, lithosphere, and hydrosphere. Atmosphere is also there, the land is also there, water is also there. So the reservoir that is containing the most water, biosphere is not an option. I mean, it's not a possible option because it is actually comprising of the whole earth. Atmosphere does not contain the most amount of water. It is the groundwater that is containing the most of water. We have seen that how much water is contributed by groundwater to the freshwater resources. Around 30 or something percentage is contributed to the groundwater, is contributed to the contributed by the groundwater compared to lakes and rivers. So option C will be the correct answer in here. Yes, like we had mentioned earlier, seen earlier. Now, which of the following statements is true? Cool air can hold more water vapor than warm air. Is it warm air can hold more water vapor than cool air? Is it cool air and warm air always holding the same amount of water vapor, or is air water is the fact that air water cannot contain water vapor? So the answer here is B, which is provided in the solution. It is because warm air, as the temperature of air increases, the space between the molecules will become larger. As a result of which, warm air can accumulate or hold more water vapor when compared to cool air. So that is why when it is hot, we feel warm air is humid compared to cold air. So the correct answer here is B. Was that. Now, another question that is coming related to the week 1 lecture series is the primary cause of water scarcity in many regions around the world. Is it insufficient rainfall, excessive evaporation, overpopulation, or poor water management practices? Option provided here is B, which I think I'll have to look into once. I'm not very sure if that is actually the correct answer. So I'll be discussing this in the next class after confirming if that is the right answer or not. Another question is, what is the term used to describe the process of water vapor turning into liquid water? Is it condensation, evaporation, transpiration, or precipitation? The correct answer is condensation. Condensation is the process by which water vapor gets transferred into liquid water. Evaporation is the other way around. When water gets converted into water vapor, it is called evaporation. Transpiration is the movement of water, release of water from vegetation into the atmosphere. Precipitation is nothing but rain, snowfall, water that falls onto the earth's surface. Next question is the groundwater withdrawn in India. What is the groundwater withdrawn in India used majorly for? Is it for industry, irrigation, drinking water, or swimming pools? Swimming pool is obviously not an option. It is also not used as drinking water. So irrigation is the right answer. The most of the groundwater that is drawn from the resources in a country goes into irrigation. So that is the 7th question in the assignment 0. 8th question is, water that is good enough to drink. What is water that is good enough to drink called as? It's called as potable water. Potable water, again, the meaning of it is water that can be used for drinking purposes. We know what groundwater is, we know what surface water is. Artesian water is nothing but free flowing spring water that comes from an artesian well. I had showed a picture of what an artesian well is. So when water that is coming out of an artesian well is called the artesian water. So that's all for today. Please feel free to post doubts or discuss in the coming sessions. Discuss about the questions that you have doubts about regarding the subsequent week's lectures. So I hope this will be helpful in help you assist doing your assignment problems for this week. I'll be around here for some more time. So if there's any doubt, please feel free to ask them in the chat box or switch on your mic and ask. Otherwise, we can meet in the next class. So that will be it for today. We'll meet in the next session with and discuss problems related to the lectures that's happening during the second week of the lecture series. So thank you. Have a good day.